Good morning, everyone. Thank you so much for joining us today in the Blackberry Field Day. My name is Shinsuke Agehara. I'm a plant physiologist located here at the University of Florida Gulf Coast Research and Education Center. So we are in subtropical or tropical climates, and we don't get sufficient winter chill for blackberry to break dormancy. That means buds cannot sprout to save flowers and fruit. That is the major problem for commercial blackberry production in subtropical or tropical climate. In today's presentation, I will talk about chemical Budbreak induction methods that can improve blackberry production where the climate cannot provide sufficient winter chill. Before talking about Budbreak induction, it's important to understand the chilling requirement of blackberry plants. Chilling requirement is the minimum period of winter chilling required to break bud dormancy. It is calculated as cumulative chill hours below 45 degrees Fahrenheit or 7.2 degrees Celsius. Chilling requirements for major blackberry cultivars are from 300 to 900 hours. This slide shows the phenology of blackberry plants in central Florida. Plants develop buds in November to December. Buds go dormant in December and remain dormant until February. Bud break occurs in late February to March, depending on the cultivar. Flowering is in March and April, and harvest is in May and June. But without sufficient winter chill hours, buds will not be able to sprout and will not produce any berries. There are three important considerations for growing blackberries in Florida. First, we will look at the importance of the location. This map shows the average winter chill hours in different parts of Florida. As you can see, south half of Florida gets less than 300 hours of winter chill, which are not sufficient for growing blackberries. Winter chill hours here at the Gulf Coast Research Center in Baum are about 200 hours. If you have less than 200 winter chill hours, there is no suitable cultivar and the yield will be very low. With 200 to 300 hours, there are a few cultivars you can grow, but the yield will be still low unless we use chemical Budbreak induction methods. With 300 to 500 hours, there are several cultivars that can produce moderate yields. In North Florida, where winter chill hours are more than 500, including Gainesville and Live Oak, there are many cultivars that will produce high yields without chemical Budbreak induction. Next important consideration is cultivar selection. There are two types of blackberry, floricane fruiting and primocane fruiting. Floricane fruiting type does not produce fruit on the first year canes. They produce fruit only on the second year canes between early May and late June, depending on cultivars. And they have relatively high chilling requirements from 300 to 900 hours. Unlike floricane fruiting cultivars, primocane fruiting cultivars can produce fruit on both first and second year canes, so they can do 2 crops a year, fall and the spring. But in Florida, fall season yield is very low and fruit quality is not good because of high temperatures. So normally, commercial harvest is only in spring between late April and mid-June. Their chilling requirements are relatively low, about 300 hours. Based on yield and fruit quality, we recommend 3 cultivars: Wachita, Osage, and Primark Freedom. Natchez produces high yields, but fruit quality is not good, so we are not recommending this cultivar in Florida. The last important consideration is chemical Budbreak induction. There are 2 types of Budbreak induction chemicals. The first one is gibberellic acid, which is a plant hormone. Although it is highly effective in inducing bud break, we found that this chemical can induce flower abortion in Natchez. Blackberry is currently not listed on the product label, so it is not available for commercial application. The other type is defoliant. We have tested 4 defoliants, including urea, lime sulfate, zinc sulfate, and potassium thiosulfate. We found that urea is the most effective chemical and also the cost is low, so we recommend urea among these 4 defoliants. This slide shows defoliation effect of urea. The cultivar is Natchez. Pictures were taken on March 3rd, 13 days after treatment. On the left-hand side, in the control, you can still find many leaves remain on the first-year primocanes. In the urea treatment on the right-hand side, you can see that there are no more leaves, so we were able to achieve 100% defoliation within 2 weeks. These pictures are from the same trial. Again, it's Natchez. Pictures were taken on May 26, 97 days after treatment. Now you can see a big difference between water control and urea. Urea treatment has much better fruit set, and that's because of the increase in bud break percentage. This slide shows the percent defoliation from the defoliant trials. In the first season, in the controlled, defoliation increased gradually and increased up to 80%. Urea and lime sulfur were able to achieve 100% defoliation. In the second season, the defoliation was much lower in the controlled, and it was about 60%. Urea was much more effective in inducing defoliation in the second season, achieving 100%, but the maximum defoliation by lime sulfur was about 80%. This slide shows the percent bud break data from the same trials. In the first season, you can see bud break was a slow process in the control. It increased gradually up to about 30%. In the urea treatment, bud break increased rapidly up to 40% and remained constant after that. In the lime sulfur treatment, bud break also increased rapidly to almost 60% and increased gradually after that up to 80%. In the second season, bud break was overall lower compared to the first season, and that's mainly because of lower winter chill hours. In the controlled, the maximum bud break was about 25%. In the urea treatment, the maximum bud break was about 60%, and lime sulfur induced about 45% bud break. This slide shows the yield data. We compare 2 different timings, December application and February application. For February application, in the first season, urea and lime sulfur application increased yield by 20 to 56%. In the second season, the yield increase was 18 to 51%. We found similar yield increases for the December application. But the main difference between the 2 timings is that when we applied defoliants in December, we were able to harvest blackberries as early as mid-April. So if you want to improve fruit earliness, December application can be a good strategy. But we have to keep in mind that if we induce bud break in December, there is a risk of freeze damage on new flowers during winter. Because of that, and also because overall yield increase was higher when we applied defoliants in February, we recommend February application compared to December application. So here is the spray guide for urea application. We recommend using urea if your area doesn't get more than 500 winter chill hours. The application rate is 167 pounds per acre. The spray volume is from 100 to 200 gallons per acre. We recommend using a surfactant. In our trials, we use Agridex at 0.5% application rate. Application timing is from mid-February to early March, just one application. We recommend making the application immediately before you see natural Budbreak. Application cost is in total $67, $53 for urea, and $14 for surfactant. Here is a summary of this study. Some defoliants are effective but dormancy breaking chemicals for Blackberry. The data I presented today were only for Natchez, which is one of the low-chill Blackberry cultivars. But we found that beneficial effects of defoliants can be more pronounced for cultivars that have higher chilling requirements. Urea appears to be the ideal chemical option because of its consistent efficacy, favorable safety profile, and low application cost. Urea application improves not only the Budbreak percentage, but also the earliness and concentration of fruit set. Improving fruit earliness may improve fruit yield and quality by avoiding heavy rainfall and high temperatures in June. This is especially important in Florida because our rainy season starts in June. Finally, artificial Budbreak induction could be an important adaptation tool not only for subtropical Blackberry production, but also for temperate Blackberry production to cope with global warming. Some commercial growers in West Central Florida are already using urea. This is the picture of Wachita. In this season, we got less than 150 winter chill hours, but you can see we got really nice fruit set. The information I presented today are available in 2 extension articles, which can be found at Ask IFAS website, edas.ifas.ufl.edu. You can find these 2 articles by using publication number or by typing the title of the article. We also share information on the YouTube channel, so if you go to the YouTube UF IFAS Horticultural Crop Physiology Lab, you can find the YouTube videos about Blackberry production, and this presentation will also be on this YouTube channel. Thank you so much for your attention. I also like to thank the funding agency, collaborator, and lab members in my program. Most of the work in this study was conducted by my former student, Dr. Xuanyo Lin, who is now an assistant professor in a university in Taiwan. Thank you so much again. I hope you found some useful information from this presentation.